So we're going to be able to calculate simple interest and total amount today. So first question here says, why should you start saving for the future? Hopefully that's, a somewhat obvious question, but at the same time. Chris Gupta's uncle gave him a surprise wedding gift. When Chris was born, Uncle Bill deposited $5,000 into a savings account. Over time, when the amount earned interest and grew, over time, the amount earned interest and grew. When Chris received the gift 30 years later, he realized that he could use it as part of his down payment on a condo he and his wife wanted. So if you set up a savings account, or if your parents have set up a savings account for you when you were born, or if you set up a savings account for any children that you have when they are born, that money will grow over time. And then once that account reaches a certain age, there should be plenty of money in that you can then gift to somebody, or that might be gifted to you at some point. And the idea is, if you put a bunch of money into it initially, that interest will grow a little bit quicker over time than if you put a little bit in and add a little bit more and add a little bit more, which is also a good strategy. As long as you keep adding to those accounts that earn interest, that's the best way to do it. Because you actually get more money for your money the earlier you start with that kind of thing. So calculating simple interest. When you deposit money into a savings account, you are permitting the bank to use the money. And we talked about this the other day with those series of videos that I showed. When you put money in a bank, the bank then uses that money to loan to other people. And because they charge interest on that loan, you are also entitled to some of that interest back in your own account. The bank pays interest, which is the amount of money paid for the use of a lender's money. So it costs money to borrow money. The most common method for calculating interest is the simple interest formula, which I don't know if that's the most common, to be honest, because most interest compounds, which we'll be talking about tomorrow. I would argue with that a little bit. Anyway, this is the interest paid on the original principal. The principal is the initial amount that was borrowed. So that's the amount of money that earns interest. Simple interest is based on three factors: the principal, the initial amount, the annual interest rate, which is the percent of the principal as earned as interest in 1 year. So the percent of the principal earned as interest in a single year. Interest rates are always based off of a year. Every single time you calculate interest, it's always based off of the year. Whether or not that interest is calculated multiple times a year, it's always based off of 1 year, which is why things get a little bit more complex as we get into compounding interest formulas starting tomorrow. The amount of time. So the other thing is the amount of time for which the principal is borrowed or invested. For example, if you take out a loan for 3 years, then the amount of time would be 3. The amount of time is also always calculated based on number of years. So the simplest way to calculate this is the amount of interest owed or the amount of interest earned, depending on if you are the borrower or the person borrowing, or the person letting the person borrow, the lender or the person who's borrowing. It's the initial amount, the principal, multiplied by the rate, the decimal, multiplied by the amount of time, which is in years. So the other way of writing this would be I is equal to PRT. I for interest, P for principal, R for rate, T for time. Interest is equal to the principal multiplied by the rate multiplied by the amount of time. So, hey guys, go and put your phones down back there. Thanks. Appreciate it. All right. Note that this formula expresses the rate as a percent and the time in years, or a fraction of a year. So T could also be a fraction of the year. If the interest is computed and then deposited into the account, you have a new quantity. So this formula here does not tell you, the interest formula does not tell you how much money is in the account afterwards. It tells you how much interest. And so the total amount of money would be the amount that's in the account plus the interest that was earned. So you have to take your value of I that you calculated before and then add it back to the initial principal value, the initial amount that you had, to get your total amount. So A, amount, is equal to P, principal, plus I, interest. So those are the two formulas we're going to be using today. We're going to be able to calculate the amount of interest and then the total amount by adding the interest to the principal value. That's what we're dealing with in today's calculations. So turn the page and let's start crunching some numbers. Example one, talking about Joyce Tyler. She's depositing $9,000 into an account that pays an annual 5.5% interest rate. We are to determine the simple interest and the amount in the account for 3 years, 3 months, and 3 days. So let's get started. So for part A, or step one, you're going to figure out the interest amount, you're going to multiply 5.5% for the given time periods. So the interest is equal to the principal amount times the rate multiplied by the amount of time. So for A, let's just go ahead and write some stuff off to the side here. For A, how much amount is being deposited? What's the amount being deposited here? 9,000. So P equals 9,000. Just go ahead and write that down over there. R, what's the rate? What's the interest rate? 5.5%. And then how do we write 5.5% as a decimal? 0.055. Yeah. So 0.055. 5.5%. Just like how we calculated taxes, right? If it was a 5% tax, it was 0.05. If it was a 4.5% tax, it would be 0.045. So percentages can always be calculated like that. And then time. What's our value of T for part A? 3 years. So T is equal to 3. Remember that T always relates to number of years. And so this is the information we're going to use for A. Let's set up B. For B, the principal and the rate should be exactly the same because it's the same amount being deposited. It's the same interest rate per year. So P is equal to 9,000. R is equal to 0.055. However, this time, what does T equal? For B, what does T equal? What's that? 3 months. Okay. So if we're writing 3 months in terms of years, in terms of a year, how could we potentially write that? Oh, no, you're reading for today, huh? I see that. Got it. Cool. Thanks. All right. All right. Easy. What's that? Yeah. How'd you come up with that? There's 12 months in a year. Yeah. If we're talking about 3 months, we can't write 3 because 3 means 3 years. T is always in terms of years. So if we write 3 again, then we're talking about 3 years again. If we write 1, we're talking about 1 year. How many months are in a year? 12. If we're talking 3 out of 12 months, that's how we could write T in terms of years. But then Kate, you said 3/12 reduces to 1/4. So T is equal to 1/4. Everybody okay with that? So when you're calculating time, that's going to be an adjustment that always has to be considered. If it's years, you just use the whole number. It's fine. But if it's months, it has to be out of 12. If it's days for part C, principal equals 9,000. Rate equals 5.5%, 0.055. However, T this time for part C is 3 days. How many days are in a year? 365. All right. So we're looking at, in terms of years, 365ths, which I don't believe reduces. Anybody check that on their calculators as fraction, 3 over 365? I don't think it reduces. So we'll just leave it like that. So we have 3 problems to figure out. 2 parts for each problem. Calculate the interest and calculate the total. So for part A, here we go. For A, we are going to calculate our interest. I is equal to the principal times the rate times the time. So we're just multiplying the 3 values together to get the amount of interest. So this will be 9,000 times 0.055 times 3, which equals, anybody have the interest there? Yeah, 1,485. Good. So the amount of interest is 1,485. That's our value of I. We also need to calculate the amount in the account. Now, this is the easy part because we take our principal value right here, principal plus the interest. So we're going to take 9,000 plus 1,485. So we're going to say A equals 9,000 plus 1,485. So we should have $10,485 in the account after 3 years. After we've earned $1,485 in interest. Or actually after Joyce has earned that much money. Because it's her account, not ours. All right. Let's calculate for B then. So there's our answer for A. So that's after 3 years. Now, question for you. After 3 months, will she have more interest or less interest than 1,485? After 3 months versus 3 years. Less, significantly less. So for B, the value of I is going to equal 9,000 times 0.055 times 1/4 this time. Or if you want to, you can say 0.25, same thing. How much interest is earned to the nearest cent? Yeah, $123.75. Great. So in 3 months, it's $123.75, which is, a lot less than 3 years. So it should be less interest, which it definitely is. All right. So the amount earned then total, or the amount in the account, is going to be 9,000 plus the interest earned, which is $123.75 for a total of $9,123.75. Good so far? Try the last one. Let's see. Figure out the interest. Figure out the amount in the account. And I would not recommend using the decimal approximation of 3/365. Type that in as a fraction. This should be the smallest amount of interest by a lot. Because we're talking about 3 days. 3 days worth of interest is going to be maybe a couple bucks. I don't know. How much is it? $4.07. There you go, just a few dollars. So $4.07, that's what it rounds to. So then we're going to add $4.07. So after 3 days, we're looking at $9,004.07. That's it for that one. So I would like you to try underneath here, problems 1 and 2. Each of them has 3 parts, just like we did here. I'd like you to try to answer problems 1 and 2 underneath. Let's take 5 minutes. We'll check back at 11:01. It's not necessarily super hard calculations, but there are definitely plenty of them to do. So I'll give you 5 minutes on this and then we'll check back in. How much interest is earned on number 1 for 4 years? What's the amount of interest? $960. Good. So that's a $960 amount of interest earned over 4 years at 6% on a $4,000 initial deposit, which means after 4 years, we're looking at 400 plus 960, which equals a total amount of $4,960. So those are the 2 portions for A. Interest 960, total amount in the account, add the interest to the original principal value, 4,960. How about for B? Let's see, $4,000 times 6% for 4 months, you could do 4 over 12 here, or you could multiply by 1/3, either way. Please don't just type in 0.3 or 0.33 because that's not exact enough. What's it going to be? 80. Yeah, it's exactly $80. If you round that, you're not going to get exactly 80. So definitely use the fraction as opposed to the decimal. $80. So that means after 4 months, we're looking at $4,080. 4080. All right. Last one for number 1 is part C. So we're looking at 4 days this time. So that would be 4 out of 365 days. To the nearest cent, how much interest is earned? $2.63. You got it. $2.63, which is going to be added here, 2.63. So we're looking at $4,002.63 for 4 days. All right. Any questions here before we look at number 2? Okay. Let's look at the next one. We're going to set this one up as well. No answers yet. $6,580 at 6.5% for 10 years. How much interest? $4,277. Nice. So if we add 4277, we're looking at, seems to be $10,857. All right. 10 months. You could go with 10 over 12 here. Totally fine. It reduces to 5 over 6. Either way is fine, though. As long as you use the fraction, because sixths do not make nice decimals. So keep this one as a fraction. So if we multiply 6580 by 0.065, 6.5%, multiplied by either 10/12 or 5/6, it'll give you the same answer. To the nearest cent, how much interest is earned in 10 months? $356.42. Yep. $356.42. All right. So if we add $356.42 to that amount, let's see. Going to be a 6, and that'll be a 3. So 6936.42. Is that right? Yeah, 6936.42. $6,936.42 is the total after 10 months. And then the final one down here, 10 days. Again, this one reduces, you could write it as 2/73 if you want to, or you could just write it as 10/365. They're both divisible by 5, so that's why it reduces. Either way, 6580 multiplied by the 6.5%, multiplied by the 10/365 or 2/73 will be interest in the amount of $11.72. So $11.72, what we're looking at there. So if we add $11.72 to that total, or to the original, we should be looking at how much? What's our last amount here for question 2? $65.91.72. Nice. Awesome. That is most of the math that you'll be working on today. Doing some multiplication, doing some adding, getting some totals. All right, next. Any questions here before we move on to some algebra? We've got a little bit of algebra on the next page, and that's it. So, all right, keep going. A couple more problems here. So it says Martin Ellis earned $150 in simple interest. So his I value, interest, is 150. He earned this over 8 months at an annual interest rate of 6%. How much money did he invest? So let's go ahead and just get some information over here. Says let P be the principal. All right, we know the value of I, so we know I. we need P, we need R, we need T. So how much interest did he earn? What's our I value here? Wait, how much money did he earn in interest? 150. Yeah, he earned 150 in interest, so 150. Do we know the initial amount? No. Okay, so P is equal to P. Because we don't know that. That's our variable. What's the interest rate? It's our R value. 6%. So 0.06. How much time has it been invested for? 8 months. How would we write that in terms of years? Yeah, 8/12, which then reduces to 4/6, which actually equals 2/3, if you want to. Because these each divide by 4. So 8 divided by 4 is 2, 12 divided by 4 is 3. You could write any one of these three fractions for t, and you'll be fine. It doesn't matter which of those three fractions you use. 2/3, if you write it in simplest form to begin with, the numbers you're going to be dealing with are a little bit smaller. So I'm going to use 2/3 for t. So what we do is we throw those into our interest formula. We know that the amount of interest is 150. We don't know the value of P. I'm going to put that at the end because that's our variable. So variables usually go at the end. So I'm going to write the rate 0.06 multiplied by 2/3 multiplied by P. So that's our equation. We got to solve for P. And again, I put P at the end because when you're solving for a variable, variables usually go at the end of the equation. So what do we have to do first? What's that? So we are going to do that second just because we got two things that need to be multiplied together here first. Yeah, so let's go ahead and multiply 0.06, multiply that by 2/3, which is 0.04, which is a great number. Like that's a fine decimal to use. You could write 4/100ths, you could write 2/50ths, you could write 1/25. 0.04 though, as a decimal, that's a fine decimal. Let's just use that. So it would be 150 equals 0.04 P. All right. Now, question for you. If he earned $150 of interest, is the amount that he initially invested more or less than the amount of interest he earned? More. Yeah, it should be a lot more. So if we divide both sides by 0.04 to get P by itself, because that's what we're doing here, we're solving an algebraic equation, 0.04, divide on both sides. What is 150 divided by 0.04? $3,750. So the initial investment was $3,750. Cool. Answer number 3 on your own. I'll give you 2 minutes for that, and then we'll take a look at number 4 together. If you want to try number 4, you're welcome to do that, or if you want to wait, that's fine too. I'll leave this up here though. So I want you to try number 3 on your own. I'll give you 2 minutes for that one. That one should be a little bit quicker than the ones we did on the last page. And then see what you come up with there. We'll talk about that, and then we'll look at number 4, and then we'll be done with our notes. How much money was invested for number 3 initially? We have the initial investment value for number 3. $2,000, yeah, $2,000. So Brenna O'Connor earned $120 in interest. That's I. She invested it for 9 months, 9/12, which is 3/4, which is 0.75, at 8% annual interest, so 0.08. How much money did she invest? Solve for P. So it's the exact same setup as the last problem. So we got I is equal to the rate multiplied by the amount of time multiplied by the initial investment. 0.08 times 70 times 0.75 is 0.06. So we get 120 equals 0.06 times P. Divide by 0.06, P equals $2,000. So the initial investment was $2,000. All right. Good. Cool. Last problem. Let's take a look at the last one here. What annual simple interest rate must Hosea Sokolsky earn to have $80,000 increase to $90,000 in 2 years? All right. This is going to use the same formula we just used. But the way that it's worded, there's some implications that we have to account for here. So we're still using, write this down, I equals P times R times T. So off to the side, I, P, R, T. Those are our values. So my first question for all of you, let's take a look at that very last one, number 4 on the 3rd page. First question here, what's the amount of interest that is earned? What's that? It doesn't straight up tell us, but it is something that we can figure out very quickly. What was it? How much money did Hosea earn over the 2 years? Yeah. How come? Why do we know he earned $10,000 in interest? Yeah, he started with 80,000. He ended with 90,000, which means the account gained $10,000 in interest. Good there? So I is 10,000. That's how much interest was earned over 2 years. What was the initial investment? 80,000. Yeah, 80,000 was the initial investment. Started with 80, ended with 90. So this is A, but we're not using A. We're using P. The difference between A and P is I. The difference between the new amount and the principal amount, the initial amount, is the amount of interest that was earned, which is $10,000. The amount that was initially invested was $80,000. Do we know the interest rate? No. So R equals R. That's our variable. And then T is just straight up 2. Yeah. How do we know it's 2 and not a fraction? Because it's what? Because it's years. Yeah. Time is always in years. And if it just says 2 years, we can just use the number 2. Great. Yeah. Yep, and it says what annual interest rate. So yeah, that's why when you're given an interest rate, it's always based off of the year. And so you need to compensate for that annual rate based on how often something is happening. And right now, we're just talking about just straight up 2 years. So we don't have to worry about fractions on this one at all. We are solving for R. So let's throw those into our formula. Put R at the end though, because variables usually go at the end. So we're going to say 10,000 equals the principal of 80,000. I'm going to say times 2 and then times R. Because variables should go at the end. So go ahead and finish that up. The way that it was asked made it a little bit more challenging, but we're still using the same information that we've been using the last couple of problems. So solve for R. And then also write your answer as a percentage because we're talking about annual interest rate as an answer here. So your R value will not be written as a percentage. It will be written as a standard decimal. So then you need to convert that back to percent for your answer. What is 80,000 times 2? 160,000. So how do we get R by itself? Divide by 160,000. What is 10,000 divided by 160,000? 0.0625. What is the interest rate? Right. 36.25%. So when we're talking about interest rates, bless you, we're talking about interest rates specifically when you get the decimal value for that. If you're writing an answer for an interest rate, just be sure to convert that back to a percentage. And that's our lesson for today. Simple interest. Hopefully it felt relatively simple. Tomorrow, like I said, we're going to get into more complex measurements of interest and calculating, which I think are more reality based than what we saw today, but this is a good start.